Hello, everybody. My name is Masood Olia, and I'm a professor in the School of Engineering at Wentworth University, and I'm here with a problem related to the subject of dynamics, and the topic is uh, kinematics of rigid bodies. And let's get started working on this problem. So let's read the statement of the problem. It says a stamp S located, right, on the revolving drum is used to label canisters. So we want to, use this drum to label canisters, right? So this is where the label is going, right? It says if the canisters are centered 200 millimeters apart on the conveyor belt, determine the radius RA of the driving wheel and the radius RB of the conveyor belt drum, so that for each revolution of the stamp, it marks the top of the canister. So basically, they're 200 millimeters apart, right, from center to center. And we want to determine the dimensions of the two, the radii of the two wheels. And then there's a second part to this problem. The question is, how many canisters are marked per minute if the drum at B is rotating with certain angular speed? And then it says that note that the driving belt is twisted as it passes between the wheels. The reason it's twisted, so normally if you have, belt going around two pulleys or two wheels, if this guy is rotating this way, then the other wheel is also rotating in the same direction. But if you twist it, like the way it's shown, right, then one would go, if one would go, say, clockwise, the other one would go counterclockwise, which is the direction that you see here. So that's the reason, by the way. Kind of like gears. You know that gears are also the same way, right? All right, so let's start solving this problem. So let me actually remove my camera so you don't have to be distracted. So let's go and start working on this problem. So we say, okay, the length between the two centers, right, is equal to 200 millimeters, right? And that we can relate that to RA or RB. So we say the circumference of the wheel A is 2 pi R, and that has to be 200. So you could easily then solve for RA. 200 divided by 2 pi. So that comes out to be 31.8 millimeters. So the radius of this wheel has to be 31.8 millimeters. So you could say the same thing about this one. We want it to go also 200 millimeters, obviously. So the same thing applies to RB. 200 over 2 pi, that would be 31.8 millimeters. Okay? So now this part, so that was very easy. So it says how many canisters are marked per minute based on rotation of this guy, right? See, there is a shaft here that is connecting the motion of this guy, and it gives you the same motion here for the wheel B. So question is, if omega B is 0.2 radians per second, and this is a constant angular speed, you could say, well, I can go ahead and then calculate how many degrees or how many radians in this case, of course, this guy is going to rotate, wheel B is going to rotate. So we'll set that equal to 0, and we say, okay, 1 minute, 60 seconds, right? So we have 0 plus 0.2, that's given, times 60. So you see the unit of this guy is radians per second. This is second. So this comes out to be 12 radians, right? And then you know that this is basically saying that, okay, if now we know that this guy is going to go through so many radians. So if this is angle theta, the arc length S is related to R. So S equal to R theta, right? Of course, theta has to be in radians. So let's find out what is S. S, which is related to that 200 millimeters eventually, is equal to R of B, right? Which is 31.8 millimeters times 12 radians. So that comes out to be 382 millimeters, right? So this is millimeters and this is radians. So in 1 minute, this guy is going to go through 382 millimeters, which is basically translated to A, which is moving this guy, right? This wheel, right? This drum. So then you say, okay, 382 covers in 1 minute how many? 200 millimeters. Now it turns out that so if you call that N, number of what did we call that? Number of canisters. So many canisters are marked per minute. So that's not going to be even 2. It's about 1.91, I believe. But you could actually adjust the radius, right? The radius of, actually, you could adjust the radius of this guy so that, this could, we could have 2 canisters per minute, okay? But in this case, based on the dimensions that we have in 1 minute, almost 2 canisters are stamped, okay? So it will, so basically if you wanted 2 canisters stamped, that's about a little bit more than 1 minute. So maybe 65 seconds, 66 seconds, and so on. All right, so let me put my camera back on. So as always, guys, I appreciate if you like the video and subscribe to my channel. I'll come back always with new videos, different topics. Thank you for watching and listening, and I will see you soon.